Hi, for this recording, I'm going to show you how fx equal to x squared sine 1 over x when x not equal to 0 and fx equal to 0 when x equal to 0 is continuous at x equal to 0. Now for this, I need to use a result called the squeeze rule. So let's go to my PowerPoint. For squeeze rule, which is on page 137 of the text by David Brennan. It says that if you have three functions f, g, and h are defined on an open interval I, and c is a point inside the interval I, and suppose three conditions are satisfied, say gx is less than or equal to fx, less than or equal to hx, where x inside the interval, and gc equal to fc equal to hc for that particular point c, and g and h are continuous at point c, then f is continuous at the point c. So in this case, our function need to establish an interval first. So therefore, I'm going to say our point of interest is x equal to 0. So I'm going to pick an interval contain 0. Let's say let I be the interval. Let's say open interval from -1 to 1. So C belong to I. It doesn't matter whether I is -1 to 1 or -2 to 2 or -infinity to infinity. It doesn't matter in this case. Now, I need to establish three functions f, g, and h. So first of all, let's make some observation about sine of 1 over x. First of all, we know that sine of 1 over x is always between 1 and -1. As long as x is not equal to 0. Now, this is not fx yet, but if we multiply everywhere by x squared, since x squared is positive, so the inequality will not change. So I get minus x squared less than or equal to x squared sine of 1 over x less than or equal to x squared divided by x not equal to 0. But x squared times sine 1 over x is actually f of x. So that means that this is f of x less than or equal to x squared greater than or equal to minus x squared for x not equal to 0. But this is not enough because I must show that according to the result, I must show that f of x must be in between gx and hx for x every x inside the interval. Therefore, I have ignored x equal to 0. What happens when x equal to 0? Note that also f of 0 is what? F of 0 is equal to 0. Therefore, we know that f of 0 we know is equal to 0. Definitely is less than 0 square and greater than or equal to minus 0 square. So combining these two together, we can say that now f of x combine inequality, we can say that now f of x is less than or equal to x squared greater than or equal to minus x squared for x belong to I, where I is the interval from -1, open interval from -1 to 1. This established the first condition required by what we call the squeeze rule. Fx is greater than or equal to gx less than or equal to hx, where in this case we can say that my gx equal to minus x squared and hx equal to x squared. So I have established a condition fx is less than hx less than or equal to x greater than or equal to gx for x belong to the open interval I. I is equal to -1 to 1 open interval. That is the first condition. Second condition we need to check now for the squeeze rule. is, in this case, g of c is equal to f of c is equal to h of c. Now the point c is 0. So let's go back to the working here. Here c is equal to 0. Now what is f of 0? F of c is f of 0. In this case, by definition, f of 0 is equal to 0. Right? Fx equal to 0 when x equal to 0. Now how about g, c, and hc now? G of c equal to minus 0 x squared because gx equal to minus x squared. So gc is minus 0 squared is also 0. What is h of c now? H of c is, in this case, 0 squared because fx equal to x squared. So h of c in this case is equal to 0 squared. It's also 0. Therefore, g of c equal to f of c equal to h of c. So the second condition is satisfied. Alright, now the third condition. So let's look at the third condition. In this case, the third condition says that g and h are continuous at c. So therefore, my gx here, I know is minus x squared. H of x is x squared. They are both polynomial, so they are basic continuous function because as they are polynomial. As a polynomial, therefore they are continuous at 0. So they are continuous at 0. So the third condition are satisfied. So the conclusion in this case is f of x now is continuous at 0 by the squeeze rule. Again, so let's remind again, the rule being used is called the squeeze rule, given in page 137 in David Brennan. That ends the recording.